Okay, the more control we get, the more complicated things are going to get. 3.4 else if statements. Starting off with our notional machine, we have a block of code on the left. Read over that block of code, see if you can figure out what is going on. Starting at line 1, we are declaring and initializing an integer variable named hour and assigning it the value of 15 that is in our stack memory. On line 3, we're asking if hour is less than 12. We're asking if 15 is less than 12. That is false. We will skip that block of code attached to that if statement. We go to line 5 where we now see the else clause, but it's immediately followed by another if statement and another Boolean expression. Here we are asking if hour is less than 18. 15 is less than 18. That evaluates to true, which means we will execute the algorithm attached to this if statement. In the console, we will print good morning, and then we will skip the else on line 7 because we already had something evaluate out to true. We need to decide how many questions did we have to ask. In this case, we only needed to ask 2 questions, if the hour was less than 12 and if the hour was less than 18. Let's look at another example. The hour has been changed. Hour is now initialized to 8. On line 3, we ask if 8 is less than 12. That evaluates to true. We print good morning in the console because we execute that block of code attached to the if. We skip the block of code attached to the else if on line 5. We skip the block of code attached to the else on line 7. How many questions did we ask? In this case, we just asked one question. When there are 3 possible outcomes, we might only have to ask one single question to get our answer. We might ask the correct question first. Let's look at our last scenario. Hour has been changed to 22. Line 3, we're asking if 22 is less than 12. That is false. We are going to skip that block of code attached to that if. We move on to line 5, where we have our else if. We are asking if 22 is less than 18. That also evaluates to false. So we execute the algorithm attached to the else on line 7. In the console, we are printing good evening. The question that we want to get to, how many questions did we have to ask? We only asked 2 questions. When there are 3 possible outcomes, you only have to ask 2 questions maximum. If we know our first 2 guesses were wrong, then it can only possibly be that third outcome, and we do not need to ask that third question. This leads us to another new statement, the else if statement. Still, it's the same learning objective. Represent branching logical processes by using conditional statements. Previously, we had seen questions that only have 2 possible outcomes. So if you asked me if I was Spider-Man and I said no, you don't need to have a follow-up question. Or if you asked me if I wanted some Pepsi to drink and I said yes, you don't need to ask me if I don't want Pepsi. You don't need to ask that follow-up question. Now imagine you go to a party and they have 3 possible drink choices to choose from. If you went to the host and said you would like a drink, the minimum number of yes no questions the host needs to ask you to determine what drink you want is 1, and that is if they ask you the correct question the first time. The maximum number of questions they need to ask you is only 2. So that might look like if they asked you if you wanted Coca-Cola and you said no, and then they asked you if you would like Sprite and you said no, well, then that means you must want the Orange Crush because that is the only option left. Now imagine for a moment you took a math test and you went home and you're going to report your grade. What are the number of options available? Well, there are 5 grades that you could have got: an A, a B, a C, a D, or an F. What is the minimum number of yes no questions someone would need to ask you? That would be 1 if they guessed it on the first guess. The maximum number that they would need to ask you is 4. So if they asked you if you got an A and you said no, they would ask you if you got a B. If you said no, they would ask you if you got a C. If you said no, they would ask if you got a D. And if you said no, they don't need to ask what you got. They already know. Here we see representations of our three previous types of program execution that we've seen. First is our sequential statements, where our program code is executed one line at a time from top to bottom. In the middle, we see the flowchart that represents the if statement. That is the first control flow or conditional statement that we learned. On the right, we see the flowchart that represents the if else statement. Here we see the flowchart that represents the else if statement. In this case, we can ask a series of questions until we get an answer that we want. So if the answer to the first question is true, we execute option A. But if it was false, we could ask another question. And then if the second question is true, we can execute option 2. And if it was false, we don't need to ask the third question. We just automatically execute option 3. And then we all meet back up to continue our sequential execution. So we can see in those blue boxes, option 1, option 2, option 3, when our number of options is 3, the minimum number of questions we would have to ask is 1. That's if that first if statement evaluated out to true. The maximum number of questions we would need to ask is 2. From our party example, step 1, you go to the party. If you want Coca-Cola, then you pour Coca-Cola and you go back to the party drinking your pop. If you did not want Coca-Cola, the next question is if you want Sprite. If you want Sprite, pour the Sprite, go back to the party. If you didn't want Sprite, then you pour the Orange Crush, and then you go back to the party. Now, with the else if statement, we can ask as many if statements as we need. Here is a bigger example in which we have 5 options. When we have 5 options, again, the minimum question is always going to be 1. We get that question right the first time. The maximum number of questions is going to be 4. If we got 4 questions wrong in a row, we know the only option left is the 5th option. So if your question has n options, the maximum number of conditionals is n minus 1. Here we take a look at that else if statement. The description, a conditional statement that if false presents another conditional statement. A lot of this should look very similar. There's nothing new. We are just structuring it a little bit different. We still have our if clause to begin with. We have the Boolean expression after it, and then we have the algorithm. After the algorithm for the if, we have the keyword else, and then we start right over with another if statement. We can keep adding if statements after else clauses to create as many questions as we need, and then we could have that final catch-all else at the end. Here we see a working example where we have 2 integers. We want to know one of 3 things. We want to know if either A is bigger than B, or if B is bigger than A, or the only other option is if they are equal. So there are 3 possible outcomes when comparing A and B. If there are 3 outcomes, we only ask 2 questions. On line 4, you can see we are asking one question. If A is bigger than B, then we will print out A is bigger. On line 6, we are asking our second question, is A smaller than B? In which case, we will print out B is bigger. And if we did not print out anything, if we didn't execute the algorithm attached to the if, and if we didn't execute the algorithm attached to the else if, then our only possible option without asking the question is that A and B are equal, and that attaches to our else on line 8. You can have as many else if statements as you want as long as the structure starts with the if first. Then you need all of your else ifs, and the last one in there needs to be the else if you are going to include it. This aligns with another lofty essential knowledge. A multi-way selection is written when there are a series of conditionals with different statements for each condition. Multi-way selection is performed using if if-else-if statements such that one section of code is executed based on the first condition that evaluates to true. So just like our if-else statement, one and only one of these algorithms will execute. Here is the example for reporting your letter grade. If your score was greater than or equal to 90, we're going to say you got an A. If not, we're going to ask the next question. Was your score greater than or equal to 80? If so, we're going to report that you had a B. If not, we continue and ask the third question. Is your score greater than or equal to 70? If so, report the C. If not, we ask the next question. Is your score greater than or equal to 60? If so, we report the D. If not, then we just report that you have an F. 5 different possible outcomes, 4 questions, and an else. As soon as one conditional evaluates to true, no other conditionals will be evaluated. So if your score was an 85, we don't print the A, but we do get into line 5 to print the B, but we don't continue with line 7. We don't ask if 85 is greater than or equal to 70. It is. We don't print the C because we already printed something. The else if on line 5 triggered, so we don't ask any further questions. Here we see another example. We are declaring and initializing an integer variable named number and assigning it the value of 10. And then we're asking if number is greater than 0. If so, we're going to print out number is positive. And then we have an else if number is less than 0, we're going to print out that the number is negative. You'll notice that we do not have a final else clause on the end. You don't need that final else clause. That final else clause is not required. You can have an if without an else. You can have an else if without an else. The first statement that we learned was just the if by itself without the else. The only thing these statements definitely need to have is the original if. Then you can put in as many else ifs as you need in the middle, from 0 up to as many as you need, and then you could put up to one else all the way at the end if you need it. That's going to bring us to the end of this lesson. Make sure you rate how you feel on that learning objective, read over your recap statements, hit me up with any questions or concerns that you have regarding this content, join us in our next video, and keep programming.